Please write today's learning target. I can use properties of trapezoids and kites to find missing angle and side measures. Trapezoids and kites are also quadrilaterals. This whole unit will be learning about quadrilaterals. Quadrilateral just means that it's a shape that has four vertices. The first thing we learn is that a trapezoid has the two bases are parallel, right? So two parallel lines. These arrows right here, this arrow and that arrow, they mean parallel, okay? That's how you know that something's parallel. So from now on, anytime you say something is described as a trapezoid, you can assume that these two bases are parallel. It does not necessarily have to have these two arrows if the instructions say that the shape is a trapezoid. Okay, so going way back to our parallel line lesson, when we have two parallel lines that are cut by a transversal, then we end up with supplementary angles. So this angle and that angle right here. Angle A and angle B add up to 180 degrees. Okay, and this side, angle C and angle D add up to 180 degrees. Do angle A and angle C add up to 180? No. Do angle B and angle D add up to 180? No. All right, so it's just right here and right here. If the other ones happen to add up to 180, that's just happenstance. That's not a specific trapezoid rule. Okay, so let's go ahead and use that information. If measure of angle A is 100 degrees, so angle A 100 degrees, and measure of angle D is 75 degrees, so angle D 75 degrees right here, right? Then find measure of angle B and C. So this side right here, that would be 180 degrees, right? This side right here, these two angles add up to 180 degrees. So how do I find measure of angle B? Well, if angle A and angle B have to add up to 180, then 180 minus angle A gives me angle B. So 180 minus 100 equals measure of angle B, right? And 180 minus 100, that is 80 degrees, right? So there we have our answer there. This is 80 degrees. Now that I have three angles, I can either add up all three and subtract from 360, or I can just say, oh, angle C and angle D, they have to add up to 180. If I'm given angle D, then if I subtract that angle D from 180, it'll give me angle C. So 180 minus 75 equals measure of angle C. 180 minus 75, that is 105 degrees. So 105 degrees is our answer. Okay. I always like to go back and make sure to label my angles with the right degrees so that I don't confuse myself later. Moving on. We also have a special type of trapezoid called a isosceles trapezoid. In an isosceles trapezoid, we have this side right here, which is length AB, is equal to length CD. So this length is equal to that length. Okay? And this tick mark right here, that's what that means, is that this side is equal to that side, the side lengths. Okay? Now, because the two side lengths are equal, then we're also going to end up with some equal angles. Only if we have an isosceles trapezoid. If it's not isosceles, if this side is not equal to this side, these rules do not apply to your angles. So this angle right here has to be equal to this angle right there if it's an isosceles trapezoid. How do I know if I have an isosceles trapezoid or not? Well, I know because either in the description it'll say that the trapezoid is an isosceles trapezoid, or I'll know because the trapezoid will either have these two tick marks that say the two sides are equal, or my trapezoid might show that these angles are equal the same way that we have here, where angle A is equal to angle C and angle B is equal to angle D. If it says that, then I also know that it's an isosceles trapezoid. Okay? So, same as before, we also have that this side, well, not side, angle C and angle D added together equal 180. And angle A and angle B added together equals 180. That rule is because of regular trapezoids. But on top of that, angle A is also equal to angle C, and angle B is equal to angle D, and side AB is equal to side CD. Okay, so how do we use this information? Well, let's go ahead and use it to solve this. All right, so we have, I'm going to start with marking. This side is going to be equal to that side. Okay. This angle is going to be equal to that angle. And this angle is going to be equal to that angle. Okay? And then also my two angles are going to add up to 180. So it tells me to solve for measure of angle S, measure of angle R, and X. So I'll start with X. So I just have my two green sides are equal to each other. So 3x is equal to 12. Divide both sides by 3. X is equal to 4. First thing out of the way. All right, moving on. It also asks for measure of angle R. Well, angle R is equal to angle Q. Measure of angle R is equal to measure of angle Q, right? Well, measure of angle Q is 110 degrees, so measure of angle R also has to be 110 degrees. Why? Because it's an isosceles trapezoid, not an irregular trapezoid, just isosceles. Okay? All right, moving on. Now it says to solve for angle S, because we got R, X. All right, so for angle S, I can use my rule saying that this angle plus that angle equals 180 degrees. And angle R we solved, we said it was 110 degrees. So 110, it's 180 minus 110 degrees. That is going to equal measure of angle S, right? And 180 minus 110, that is 70 degrees. So okay, moving on. Kites. Okay, so a kite is a shape where we have two pairs of congruent consecutive sides. So that just means that this side is congruent to that side, right? How do we know? These tick marks, double tick marks, right? This side is congruent to that side because single tick marks. Okay, so BC, we got that in our green. Okay, we got this in our, we've got that in our orange, and then EC is equal to EA. So EC, that's on the inside here, is equal to EA. All right, so I'm going to go ahead and put a triple tick mark there to remind myself. Those two are also going to be equal. Next, we've got our angles. All right, so BCE is angle BCE is equal to angle BAE. So BCE, that's this angle right here. That part is in blue, is going to be equal to this part right there. Okay? Then we have angle, so that's my blue, angle ECD, so ECD, this angle, is equal to angle EAD, so EAD, so that's this angle right here. So those two angles are equal. Next we have angle BCD, so BCD, so that's this whole angle, that's the one in pink and blue. It's equal to the measure of angle BAD, pink and blue. And then angle CDE, how do I find that one? Let's see, CDE. So that's this angle. I'm going to do a double angle mark, double arc mark. And then that angle is equal to ADE, so ADE, so this one right here, double arc mark. And I'm going to go ahead and give that a yellow color. So that was our yellow. And then last thing is all the angles in the middle are all right angles. So BEC, so that's going to have a right angle. DEC, so DEC, that's right angle. BEA, BEA, it's right here. And DEA, DEA, so that's this one right here. So you have all right angles in the middle. Okay, so that's the way that a kite works. When you look at your practice problems later, problem number 17 works this way. You just have to mention which things equal each other, right? So if you look back to this, that's how you answer problem number 17 on your practice problems. Okay. Next, let's actually use this information. If AC equals 10, so let's see, AC, that's this whole length, that equals 10, and EC is 5. Well, if EC is 5 and this whole thing is 10, that whole thing's 10, then this also has to be 5, right? ED is 12, so ED is 12. I'm still using what was given to me, and EC was 5 given to me. Solve for CD, AD, and all that other stuff. All right, let's see, CD. Well, CD is this hypotenuse, okay? And we have a right angle, and we have a leg and a leg. I could use Pythagorean Theorem to solve for CD, right? And Pythagorean Theorem says that leg squared plus leg squared equals hypotenuse squared. Or you saw it as a squared plus b squared equals c squared. I just make sure to put the hypotenuse on that other equal sign, so that's your c always. Your a and b, it doesn't matter which one you call which. Okay? So here we go. Leg 5, so 5 squared plus 12 squared equals my hypotenuse squared. So hypotenuse was CD, so CD squared. Okay. Next, that gives me CD squared though. I don't want CD squared. I want CD. So how do I undo that? Well, I take the square root of all of that. There. Now I'm going to plug this into my calculator. Square root of 5 squared plus 12 squared. Okay? And I get 13. So CD equals 13. Okay. Next, AD. Well, either I can do the same thing again, 5 squared plus 12 squared equals this, because that's also a hypotenuse, or I can see like, oh, a kite, therefore this side has to be equal to that side. They even put the tick marks there to remind me. So double tick mark, these two sides are equal. So this should also be 13. Okay? So I'm done with my sides. All right, so moving on. Now my angles. Angle AED. So AED. So that means that this is my angle in the middle right here. And guess what? When I marked my kite before, that angle, we said it has to be a right angle. So right angle, that means is 90 degrees. That's simple. Angle ADE. ADE. I'm going to put a single tick mark, single arc mark there. Okay? So in order to solve for this angle, I am given two sides, and my angle is my question mark. What I'm gonna do is I'm gonna go ahead and mark my triangle from this angle that I'm trying to solve. That side is my opposite side, right? This side is the hypotenuse, and this side is the adjacent side, right? So what actually is marked on my triangle? I have A, my adjacent side, and my opposite side marked. Okay? And then let's remember, so, ka, toa. What do I have? I have O and A, right? So that's tangent, right? So if my angle is my question mark, then I'm going to use the inverse function, right? So tangent inverse of O over A, right? O was 5 and A was 12. Tangent inverse of that gives me my measure of that angle. So that was angle ADE, right? So I'm going to plug this into the calculator, and then I get 23 degrees. So next, ask for angle CDE. CDE. Oh, guess what? Those two angles are congruent. How do I know? Well, if I look back at what we just marked, it showed me that these two angles were congruent. So measure of angle ADE is equal to measure of angle CDE. So measure of angle CDE is also equal to 23 degrees. All right, and moving on. Angle CDA. So CDA. Well, if I look at angle CDA, it gives me one of these angles and another of these angles. Those two angles, they're both equal, right? So I just have 2 times this angle to give me angle CDA. So measure of angle CDA is equal to 2 times measure of angle either one of these, so ADE. Okay, so that equals 2 times 23 degrees, right? And then, so measure of angle CDA is equal to 46 degrees. All right, and that's it. Those are kites, and we did trapezoids, so we're all good.